Good evening, ladies and gentlemen. It's a pleasure to welcome you to this, the 30th Norma Berryhill Lecture by the UNC School of Medicine. I'm Bill Roper, Dean of the school, and it's my privilege to welcome you here to this, which is our fall convocation. The tradition of the Berryhill Lecture, which celebrates the contributions and the memory of Norma Berryhill, is a very important tradition in the life of our medical school. And you'll hear more, see more about that in just a little bit. I'd like to introduce a number of very special guests. First, I would say I would be introducing Chancellor Carol Folt to you tonight, but she wasn't able to be with us. Those of you active with the university know today's been a very busy day for Chancellor Folt, and it continues. She's got various things on into the evening, and I think she's doing a marvelous job of leading our university today. We have present with us, though, Chancellor James Measer and his wife. James, we're glad to have you with us. My distinguished predecessors, Jeff Haupt and Stuart Bondurant, thank you for being here, and their wives. Also with us is Kat Berryhill Williams. Kat, we're delighted to have you with us. And Jane and David Meyer, who are Kat's daughter and son-in-law, excuse me. And we have in this, what we think is the largest Berryhill crowd in a number of years. Thank you for being here. We have a number of former previous Berryhill lecturers, and I'd like to recognize all of you. So as I call your name, would you please stand, and then we'll salute you with applause at the end, please. First, Stuart Bondurant, who was the 1993 lecturer, Jeff Haupt, the 2009 lecturer, Phil Bromberg, 2004, Shelley Earp, 2007, Ron Falk, 2011, Gene Oringer, 2012, Joe Pagano, 1997, Harold Roberts, 2003, Fred Sparling, 1999, Jenny Ting, 2010, Judy Tintinelli, 2013, Frank Wilson, 1996. Thank you all for your being here. And I want to especially thank, before I forget it, the team of people who worked so very hard to put this evening together. Carol Edenton, Marie Mitchell, Cheryl Jarman, Karen McCall, a number of others. Thank you all. People worked really hard to make this possible. And since this is our 30th such celebration, they put together a little video that we want to show you. So would you please, wherever I'm looking, turn it on.
She was beautiful, she was smart, she was kind as she could be, and she was tough as nails.
Norma Berryhill, she was a larger-than-life figure with a brand name with great warmth and humility. She demonstrated an interest in who you were, what you were doing, what you were planning on. It was that was the personality of that family. And that was important to the growth of this medical school.
It was always very clear that she really believed in the sense of community of the medical school. That was a big part of her input to the school. She felt very strongly that the faculty should know each other, we should interact socially.
They had dinner parties all the time. And my sister and I were the servants. We hung up the coats and the hats, and we served the plates and moved the plates and served the plates for the next course. And after everybody was gone, we washed the dishes. And I washed a heck of a lot of dishes.
She often would invite people to her house. There would be big Christmas parties, and always would emphasize the importance of not only having the faculty and their spouses, but their children.
Reese Berryhill was dean when I first came in 1946. With his wife, Norma, the two of them created a sort of a community of this generation of new recruits who were the founding faculty of the clinical part of the medical school. She went to extraordinary ends to make them feel at home.
Chapel Hill was really a village, and so you sort of knew everybody.
I think that she built on what was an ambience of Chapel Hill. She built on that and extended it to create really a sense of family among all of the faculty of the medical center.
I think everybody felt that sense of being a part of a bigger whole, and that just was just a part of her. She enjoyed doing that. And I think it helped Dean Berryhill a great deal to kind of get the school moving in the right direction. And I think it had a lot to do with this collegial atmosphere of UNC, where there's tremendous support among the faculty. It's not a dog-eat-dog environment. Tend to enjoy helping each other. There's something here that's a little bit beyond these other places I've seen. It's almost hard to put your finger on, but it's on the other hand, it is palpable. Well, I think it's been a very successful idea that Stuart Bondurant initially had in the mid-1980s. The idea at the time was we have faculty who achieve national and international recognition, and some of them aren't known locally as well as they are internationally.
And so that's what was the germ of the idea, that we should take advantage of the wisdom that was among us and was being distributed all over the world, but not being distributed locally. I invited suggestions from all over, who can we name it after, and I was just so conscious of what Norma had given to the place, independent, in addition to Reese, different from what Reese gave it, and her legacy was still around.
It's hard to leave Chapel Hill. Once you're here, you love the place. And for many of us, I can't imagine leaving because it's been such a great environment to work in. And I think Mrs. Berryhill saw that, Dean Berryhill saw that.
We would never have succeeded if people had come and left. So most of the people working on the problems I'm working on have been here minimum of 10 years and most 20, 30 years, all working together effectively. Our faculty, who are very well respected in many, many different fields, are each respected in their field for their contributions, and there's no centrality of such recognition. Some of the people that we've been able to hire here, and I can say this with great assuredness, we've seen like blossoming like a flower, that people who were unhappy or less successful somewhere else but who had tremendous skill sets suddenly come into their own and are tremendously successful because of the culture. It's a small town where contributions can be recognized, where leadership is important, vision is important, strategy is important, and the degree of benefit from the investment is very large. I think that Dr. and Mrs. Berryhill had a vision that has been realized, that as we recruit people here, the idea that they're part of a family, that it's a small town and that it's a safe and secure place, that people will respect the aspirations of new faculty, that faculty will have an opportunity for collaboration that would be impossible almost anywhere else. That's all true, and that's why a lot of people move here and stay here for their entire careers.
Well, you have a sense of awe at how productive people have been and how some of your closest friends have done so much that will ultimately improve the life of mankind.
In keeping with the Berryhill tradition, Norma Berryhill's tradition of hospitality, we want to welcome new faculty who have come to our school. And this year we've made a special point of inviting all of you who are newly come as of a year ago. And I just would ask those of you that are new faculty of the UNC School of Medicine, would you please stand so that we can salute and honor you? And now I'd like to introduce Dr. Bill Lee, who's president of the Medical Schools Alumni Association. Dr. Lee.
Thank you, Dr. Roper. I would like to extend a warm welcome to each of you on behalf of the Medical Alumni Association. I think the main mission of the Medical Alumni Association can best be expressed by a challenge that was given by the late President Bill Friday, when he said every morning, 1 million North Carolinians get up and go to work for wages which are below the poverty line so that they can pay taxes that finance our education here at Carolina. Our job is to figure out how to pay them back. The loyalty that each of you have given and many alumni have given, as well as the financial support, have made UNC one of the most prominent medical institutions in the nation. And it does make a difference in the lives of many people and helps to pay back those taxes that they pay. Our speaker today has also changed many lives globally and locally. He's a distinguished physician, teacher, and researcher. He's saved many lives around the world. But one of the things he's most noted for is his lectures at the UNC Internal Medicine Update every spring. He's one of the most anticipated lecturers, so I can assure you that we're in for a special treat tonight. The Norma Berryhill Distinguished Lecture is UNC School of Medicine's largest convocation apart from commencement. It was established in 1985 to honor Mrs. Norma Berryhill. Her husband, Dr. Walter Reese Berryhill, has been called the father of modern medical education at UNC. But he gave credit to his wife for all the support that she gave. And he said that she did, quote, more than anybody, end quote, to establish the medical school. Ms. Berryhill was born in Warren County on a tobacco and cotton farm. She attended Peace College and then transferred to UNC after 2 years, where the friendship with her future husband grew while he was a first-year medical student. After 2 years, Dr. Berryhill transferred to Boston, but it said that he wrote to his future wife almost every day. On August 2nd, 1930, Norma and Reese Berryhill were married. She observed that he had said he would not marry until he could support her, but she observed that it was in the depths of the Great Depression. She said that it helped that she had a job when they got married, though. After Dr. Berryhill served as an instructor in Cleveland, the Berryhills moved back to Chapel Hill in 1933, where he became assistant dean in 1937 and then dean in 1940, which began a time of great progress and growth for the medical school. Mrs. Berryhill provided support, wisdom, and encouragement as UNC grew into a four-year medical school. But in addition to her intellectual support, as has already been alluded to in this video, she provided a warm hospitality for both faculty, residents, and students with her teas, dinners, and parties. After the war, many of the medical students and residents had served in the military and were older and were married, and Ms. Berryhill helped to organize groups of those wives so that they could support each other. The hospitality, the warmth, and the interest that she showed in everyone truly make her the mother of the UNC School of Medicine, and I think it's only fitting that we honor her with this lecture series. Thank you.
Thank you, Dr. Lee. It's now my privilege to introduce our 30th Berryhill lecturer, Dr. Mike Cohen. His titles are many, and they're on the screen here, but just to recite them, he's the Yeargan-Bate Distinguished Professor of Medicine, Microbiology and Immunology, and Epidemiology here at UNC Chapel Hill. He serves as Chief of the Division of Infectious Diseases and is Director of the Institute for Global Health and Infectious Disease, and he's Associate Vice Chancellor for Global Health, co-principal investigator of the NIH HIV Prevention Trials Network. Mike is a native of Illinois. He went to the University of Illinois, then Rush Medical College in Chicago, served his residency in internal medicine at Michigan, and then an infectious disease fellowship at Yale, and he came here to Carolina in 1980. For those of you that need math help, that's 34 years ago. So we do believe in long investment in careers here at Carolina, and we're delighted to hear Mike talk tonight about what he has done over those years. He's received many, many recognitions, and there are just a few that I'd want to point out. They're all recited in the program tonight. But in 2008, he received the university's highest honor, the O. Max Gardner Award, presented by the UNC Board of Governors annually to, quote, that member of the faculty of the university system who during a year has made the greatest contribution to welfare of the human race. That says a lot. In 2011, his principal work in HIV treatment and prevention was recognized as Science Magazine's Breakthrough of the Year across all of scientific inquiry and discovery. In 2012, the Raleigh News and Observer named him Tar Heel of the Year, and in 2013, he received the North Carolina Award, the state's highest civilian honor. Mike Cohen is a force of nature, as someone said in her comments about him, and I have surely been the recipient of that force of nature many, many times. You're about to receive it tonight. It's my distinct honor to present to you the 2014 Norma Berryhill Lecturer, Mike Cohen.
Well, I want to thank Bill for that kind introduction, and I must admit, Bill never knows what's really going to happen, and so it's very provoking if you're an administrator and you really don't know what's going to happen next. But I did hear from several sources, be brief, and so this will not go on forever. I stand between you and the libations, and so this will be over before you know it. Having said that, I'm going to use slides, and I want to start first by indicating what I think is important is thanking, when you actually have the privilege of talking at your own home institution, there's a lot of people to thank. I know so many people in this audience who've made contributions to our work that it would be impossible to name them all. So I want to start out with a thank you. First, thank the committee for nominating me and allowing me this privilege. Second, the Berryhill family for their support of the university for all these years. I obviously knew Norma, and what I said is exactly what I think in that movie, although I worry a little about how I looked, you know. Could have had makeup. The next time we do these movies, you know, there's got to be makeup artist. Okay. Having said that, let me just use this slide to thank all the many students and fellows and faculty that I've worked with over all these years, and all the patients who've participated in our many, many clinical trials that made what I'm about to describe possible. That would be impossible without these collaborations. So I'm going to tell a story, because that's easier to think about it that way. There's going to be a beginning, a middle, and we don't really quite know the end, but we're kind of winding towards an end. This is me when I came here. It all began. That's me, because I couldn't identify myself necessarily, living in China. My wife, Gail Henderson, a distinguished scholar and chair of social medicine, is sitting next to me. And looking at that slide, the main thing I think about is I really miss my hair. So you know how you could miss something in a picture? That was great hair, and I really miss it. We went to China then, and I was in China for no good reason. So let me just assure you of that. But nothing that happened to me the rest of my life would ever have happened had I not been convinced by my wife, Gail, who's a China scholar, to go to China. So everything depended on that trip, because it taught me a lot of things about international collaboration and working in developing countries, and lots of things that were unbelievably critical to everything else that happened. We brought our infant daughter, Jessie. She's the one in the green coat there, next to the People's Liberation Army recruit. And she'll come up later in this lecture again. But so this is by way of giving the beginning and the time. So this is what we looked like when we came to Chapel Hill. Now, when we came to Chapel Hill, the very year we arrived, there was a report in the MMWR, the CDC's report that Bill Roper once ran that organization, a very important organization, and they reported 5 young men living in the West Coast, all of whom developed concomitantly an unusual pneumonia. This was a cluster. Clusters get our attention. No one really knew what was going on, and that was at that point, these are all men who have sex with men, and this became what was then gay-related immunodeficiency disease. Just kind of a note. But that obviously, from this little problem, grew the world's great pandemic of the 20th and 21st century, with a total of as many as 35 million people who've acquired HIV infection. At least 16 million people have died of HIV infection, and even today, about 5,000 people a day are acquiring HIV infection. So it would not be surprising that if you're an infectious disease specialist, you would be de facto working on, at some point, HIV disease. Now, when this disease first struck in 1981 in Chapel Hill, and then between 80 and 85, we had no idea what was causing this fatal disease. And at that time it was universally fatal. And the thing for infectious disease specialists that protects us in some way, guides us, is to learn the rules about the pathogen. What we deal with are three factors: the environment, which for us is everything; the host, which is us, the human being who can get an infection; and then the microbial world. Those are the three parameters. We try and learn the rules, and the rules inevitably lead us as medical scientists and public health people to prevention, treatment, and cure. That's where we're going. Now, I want to show a little video to orient you, which is, I think, very timely right now. We'll see it.
In a remote African jungle, a small monkey is captured, bound for a pet store in America. The animal carries a deadly virus. I know that some of us have doubts about what we're about to do. We'd be less than human if we didn't. But the fate of the nation, perhaps the world, is in our hands. We cannot, we dare not refuse this burden. I'm confident that each of you will do his duty. God forgive us. Your town is being quarantined. We got 19 dead. We got 100 more infected, spreading like a bushfire. What are you talking about? If one of them's got it, then 10 of them got it now. And if one of them gets out of Cedar Creek, we have a very interesting problem. If that bug gets out of there, 260 million Americans will be dead or dying.
I'm leaving with the team in an hour.
From the heart of a small California town. Damn it, Sam, all the states do the same as you. To the inner circle of power in Washington. The most optimistic projection for the spread of the virus is this: 24 hours, 36 hours, 48 hours. The greatest medical crisis of all time. We can't stop it. Begins. Try to remain calm. Many people are dying and are going to continue to die unless we find this monkey. There will be panic attacks of which we have never seen.
All right, this was Rene Rousseau's last movie, as far as this was her finest work. And what's important about this video is there are features of it that really do make sense. I love this movie, as you can tell, and we could watch it over and over and over. That'd be a better thing than this lecture. And especially now with the Ebola panic in this country. But the point is, it's about the rules. We are always concerned about the rules. So here's how, they said there'd be no math ever in your mother's lecture, but this has to occur today. This is how we determine the rules. We say rho, R, equals beta delta C. And rho is the average number of people that can be infected by one person. So, for example, influenza is very contagious. One person with influenza can infect 10 other people. With Ebola, just as an aside, we know that one person on the average infects 2 people. So it's not very contagious. But we're always concerned about R naught, rho. And the way we calculate that is beta, the efficiency of transmission of the organism from one person to another person, times D, how long is somebody contagious, times C, the number of people who can be exposed. This is our Bible. Our goal in preventing infectious disease is to get R less than 1. When R gets less than 1, epidemics go away. we in Chapel Hill have spent most of our lives working on beta. What's the efficiency of transmission of HIV, and how are we going to reduce the efficiency of transmission of HIV? And there's a lot of ways you might reduce efficiency. One way is if the person who's susceptible got a vaccine, they're no longer susceptible. So that's how vaccines work. Now, why did HIV cause such a huge pandemic? Because the duration of infectiousness is very, very long. It's not particularly efficient, but because people remain contagious for 10, 20, 30 years, a very large number of people can be infected. Does this make sense? Okay, so this is kind of what this looks like. And there's efficiency is a function of two factors. How much virus is present, and what does the virus look like? So how much virus is present? For HIV, we know that when you have a very small concentration of virus in the person's body, for whatever reason, they're not very contagious. When they have a lot of virus in the person's body, they're very contagious. Let's just flip for a second to Ebola. Why did the two nurses become infected with Ebola? Because a lot of procedures were being done on someone sick with a very high concentration of virus, and the virus was available in such large concentration, it would increase the efficiency of transmission. So to reduce the efficiency of transmission, we're very concerned about reducing the absolute concentration of virus. The other thing that investigators at Chapel Hill have worked on a lot is what the virus looks like. It turns out that the infected person has thousands and thousands of different flavors and types of virus in their body. This is with HIV. But there's a bottleneck, and this is a paper from Ron Swanston's group that's going to be published next month or next couple of months. There's a bottleneck, and it turns out that the virus that's transmitted has very special features. And so another way to look at efficiency is what's required for the virus to go from one person to another person. Not all viruses are willing to go. So to interrupt transmission, you need to know about efficiency, and you need to know how many particles are required, which I've shown you, and you need to know what the type of virus is that can go to the next person. Now, this is what HIV looks like, and I know it's a little complicated slide. We're not going to go through the whole slide. Here's a person who's HIV negative. There used to be a pointer here, but we'll skip that. There's a person who's HIV negative, and they're minding their own business. When they first get HIV, they get one virus, and that one virus, for the most part, it's ready to go to the next person. And that one virus is unrestrained. And see how rapidly it can grow. It grows as fast as it can to fill up all spaces in the body. That's called ramp-up viremia. So the most contagious person is the person who just got HIV with the virus ready to go to the next person, unrestrained, and the HIV antibody test we use is negative. These people have acute HIV infection, and they're of great concern to us. During that acute phase of infection, two other bad things happen. The virus goes to every compartment in the body, the brain and the testes and everywhere else. So if we're ever going to cure HIV, which we'll get to later, we need to cure every compartment in the body. Second, the virus can become dormant, latent, and that latent pool of virus hinders us from curing infection. So then the question is this: what's the deal with UNC? Why do we have, I think we can arguably say we have among the best HIV research groups in the world. Why can I say that? Because every year in U.S. News and World Report, the ultimate authority, we're always in the top 10. So we can brag on, as we would say in the South, brag on our recognition in that medical journal. But then the question is, how did we even get into this? So this comes back to a fact that many people who weren't here in the 80s, they may not know this. Dr. Kenneth Brinkhouse is unbelievably critical because Dr. Brinkhouse, a giant of medical discovery, worked on clotting disorders. And he then recognized that he could concentrate factor VIII, infuse factor VIII into people who would otherwise die of hemophilia and save their lives. And many hemophiliacs moved to Chapel Hill. And then they had children who were hemophiliacs. So when I came here, and Dr. Sparling was here with me, we managed a lot of patients with hemophilia. So this was a huge contribution, but it also created an environment where when the blood supply became contaminated with HIV, the hemophiliacs could then acquire HIV very, very readily. And so in the 1980s, we went from managing a lot of hemophiliac patients doing very well with the clotting factors to HIV-infected patients, hundreds if not thousands of them. Dr. White led a big discovery focus on, Dr. Gil White, on HIV investigation, and years later, Dr. Harold Roberts, a prior Berryhill lecturer, wrote an editorial in the New England Journal about the tragedy of the era when so many hemophiliacs died of HIV infection. Recognize, and if I can go back one slide, recognize that in 1985, more than 10% of the beds in the hospital were filled by people with hemophilia, with HIV infection, and it was 100% fatal. So you can imagine how terrible this time was for the kind of brave staff, and many of the faculty are still here. Dr. Vanderhorst, Dr. Smiley, Lynn Smiley, Stan Lemon, helped to manage these very, very sick patients. Burroughs Wellcome played a huge role. Our neighbor, which is now GSK, was a much smaller company called Burroughs Wellcome. And David Berry was the scientific leader of that company, and David Berry took helped to develop off the shelf a drug called AZT, and this drug saved the lives of people dying of HIV infection. So this was the first drug, huge breakthrough in 1987 and 88, made widely available. And then now, if you look many, many years later, we see in 2013 and 14, we have more than 30 drugs used in combination, and a patient with HIV today takes 1 pill a day and lives a normal lifespan. So imagine how far we've come from 85 to 2014. So let's talk about me. Okay, so if we get back to me, which is the whole purpose of today, so in the 80s, the notion was we were all going to work on different parts of this. And my interest was in transmission of infectious agents because our group, the group that Fred Sparling led, worked on sexually transmitted diseases. HIV, in the end of the day, is another sexually transmitted disease. My focus moved to HIV. And these, on this slide, are all the ways you might prevent HIV infection. You might change, for people who are HIV negative, you might change their behaviors. So they put themselves at much less risk. They might use condoms 100% of the time, although if everyone used a condom every single episode of intercourse, the species would die in one generation. So that's not really a solution. So you might make a vaccine, and we've been trying very hard, greatly in collaboration with Duke, to make a vaccine, and we continue to work on that. You might then try and find agents that would be given before exposure to HIV that would prevent HIV acquisition. This is what we do with malaria. This is what surgeons do before they cut and devitalize tissue. They give antibiotics before exposure to try and prevent infection from occurring. But I became particularly interested in the idea that if we treated people, we could render them less contagious and then stop the transmission of HIV. That was a very simple idea. So that became the focus. And the simple prevention idea is shown on this slide, that we were going to take couples, and everybody in this room who's in a couple, and if you look at HIV, everyone's in one of 3 buckets. If 2 people are both HIV infected, we call them concordant positive. If 2 people are both negative, which is the vast majority of people on the planet, they're concordant HIV negative. But what about when one person's positive and the other person's negative? Those are called discordant couples. Now, when we started this idea, the simple idea of could treating the infected person stop transmission to the next person, we needed discordant couples. That was the idea. And the probability of transmission within those couples at that time was believed to be about 10% per year. That is a 1 in 10 chance that the infected person, in the absence of intervention, would infect their partner. So in order to kind of pursue this idea, a lot of people at UNC put a lot of time into the work. Ron Swanstrom, a molecular virologist. Susan Fiskus, a clinical virologist. Irving Hoffman, a logistical genius who set up all of our international programs all over the world. Joe Iran, the clinical person in our group who helped so much in designing clinical trials. And Angela Kashuba, a pharmacologist that's worked with our group for a very long period of time. And when she started, and now Angela is very world famous, and I won't embarrass her too much. When we started, though, she was just coming out of her postdoc, and in order to do the work we were doing, we had to have a night shift to work at Glaxo. We didn't have any equipment, so Angela and the students would go overnight to Glaxo with the permission to use their equipment and come back the next morning having done their research on equipment that UNC did not own. I know the equipment I'm talking about now, I think we have 14 of these pieces of equipment, but this is a long time ago. So I want to really give recognition to the team at UNC that helped me so much in this work. So here's the idea, that the NIH would support a trial through the HIV Prevention Trials Network called 052. And this is a trial, a randomized controlled trial, in which we're going to use discordant couples, one person positive, the other person negative. We're going to randomize the infected person to either immediate therapy or we're going to delay the therapy. Now, we're not going to delay the therapy so long that it compromises health. We're going to delay the therapy within guidelines that are widely accepted so that everyone's going to receive therapy, but we can wait a year or two to start therapy. And during that 2-year window, it's possible to look at differences in transmission. And there's 2 endpoints here. One endpoint is, did the person who is infected, treated or untreated, did they infect their partner? And not only did they infect their partner, did they infect their partner with the molecularly same virus as they have? Because maybe they were unfaithful. Maybe they got a virus from somebody else. So we had to develop techniques, we and others developed techniques to link the viruses. The second endpoint is, did the earlier treatment improve health? Does this basic idea make sense? Okay, I'm going to say it again, because how many think this makes sense? How many don't want to be here? Okay, this is the basic study design. And again, 2 endpoints. Did we stop transmission, and do we improve health? And now there's another issue. We couldn't just give people pills and not counsel them about using condoms and safer sex and being faithful to their partners. And so we were working against our own aim. For the people in the delayed arm, and at both arms, you'd say, every time you have sex, use a condom. Always use condoms, never be unfaithful, so on and so forth. And we came to worry that maybe the trial would be futile because people would stop having sex or use condoms every time. Because when people came back to the clinic, they said, yes, we use condoms every single time, never failed, except there were 254 pregnancies. So we quickly came to realize either there was immaculate conception in our trial of some sort, or people tell you through social desirability, yes, we're using condoms, but they weren't really using condoms. So in the end, the trial enrolled 1,763 couples at 13 sites in 9 countries. So this is a massive effort. Now we go way beyond UNC. Family Health International was our key partner organizationally that helped us organize this, and then we had medical universities, many other partners. Thousands of people worked on this study, which took a very long time, as you'll hear in a second. So we enrolled 278 couples in the Americas, 954 couples in Africa, and 531 couples in Asia. We oversampled Africa because Africa is the epicenter of the epidemic. 80% of all HIVs in Africa, they have a special type of HIV, they have a high viral load. We needed to show this could work in Africa. Now, an aside, I would say the premier site, the site that enrolled fastest, did the very best work, and finished their enrollment first, was Malawi. So that's UNC's flagship site that was built by a team of UNC investigators, especially led by Irving Hoffman, Charlie Van Horst, and others, over many years. And we're very proud of having set up the site. And I think Jeff Haupt might be in a picture, I can't remember, but Jeff and Bill Roper and many of our deans have been to the site. This is how people live, very poor country in rural huts. That's our original UNC project sign. This is a building called the Tidziwi Center that was built subsequently so that we could have state-of-the-art labs in order to participate in this and other trials. This is the new sign, the Tidziwi Center. These are the lab pods. So we have to, in a very poor country, put down incredible equipment and research facilities in order to succeed in what we're trying to accomplish. This is a dormitory built for students that now we're theoretically going to build the second one. That woman in the middle is Amina Hassinapur, who's an infectious disease specialist, who's lived there 11 years and manages much of our program. That's a goat roast. In a story you could never make up, out of the picture is the cook of the goat roast, a very tall guy named Gottfried wearing a giant hat, who Jeff and Bill may remember. So on this particular goat roast, we had a congressional delegation led by David Price visiting us. So David Price started talking to Gottfried about democracy. And the next thing I knew, Gottfried quit his job and ran for parliament and had a limousine. And so the next time I saw Gottfried, he drove up in a limousine with 2 bodyguards. And I said, let me just get straight. Why are you with these? He said, I'm in parliament. And this, I believe this was completely David Price's idea. And he was a great cook, by the way. This is a dormitory for the medical students. There's a campus of the University of Malawi College of Medicine, and this is a quite important facility. And maybe what we're just so proud of is a library. That's the UNC homepage with the satellite on the roof with the UNC Health Sciences Library, probably one of the best in the world, unequivocally. And the Health Science Library has the global library, and their librarians train all of our remote sites to set up libraries for this purpose. And no one comes to this campus from a developing country that doesn't go to the library and say, can you help us have a library? That's the #1 request, I would say, for people visiting us. Now, realize that from this acorn, we were interested in HIV transmission. We were there because this is a place where you could study HIV transmission quickly because there were so many cases of HIV. 15% of the adult population was HIV infected. But from this acorn grew things that were way beyond what we ever envisioned. A surgery residency run by our general surgeons and with the largesse of Tony Meyer and Anthony Charles and other. An OBGYN residency spearheaded by our OB department and Dan Clark Pierce and Jeff Wilkinson, who lives there, and Jeff Stringer. A burn unit that Bruce Carnes built with the help of Anthony Charles and other, and with the help of Johnson & Johnson, a public-private partnership. A fistula repair unit, a reproductive health unit with people working on new contraceptive techniques, and Gretchen Stewart, was here today. Her trainees are living and working there in Malawi. A cancer treatment program with the largesse of the Lineberger Cancer Center with a pathology lab and special microscopy from our pathology group. So from this acorn, because of our bottom-up kind of work ethic of this faculty, all these things happen. It wasn't the infectious disease people who did all this. It was all the other people on this faculty who did this, which I think is a remarkable achievement. So let's get back to me again. Okay, so now back to me. Okay, so HPTN 052. This is not the way. We have a bunch of new faculty here. I don't know the number, it's 10 or 20 new faculty. This is not the way to start your career, okay? Because what happened was it took us about 15 years to do this study, as shown on this slide. This isn't the fast track. And during the development of the study, there were no abstracts, no papers, and no reports. So I was spending $11 million a year of the federal dollars with nothing to show for it. This was not popular. There were two schools of thought. One school of thought was that this wasn't worth doing, and the other school of thought was it could never be done. So there was no one who liked this study. I mean, I can say that with great assuredness. And then we never had any results because the way this works is I'm blinded. So you're overseen by a data safety monitoring board. They see the results, trying to protect the study subjects, look at what's happening, and they have the data, and you meet with them every 6 months. And there's 2 rabbis and 2 priests and 2 lawyers, and it's like a Noah's Ark of people. And so you go in the room with these people, and you sit down and you tell them what's happened the last 6 months. You fill them in, not about your study, because they're the only ones with any data about your study. You fill them in about the field. Have there been discoveries that would affect their thinking? They're very smart people, and you sit down, and then they would make recommendations sometimes, or there'd be no recommendation. And because the study went on for a decade, we got to know these people very, very well. And usually there were no recommendations, or very small recommendations. One time, there was a very unusual recommendation. We had a site in Thailand, and they said to me, in Thailand, the index cases taking their pills, but they no longer have a sexual partner. How are you going to replace their sexual partner? So I said, and this is a written, I said, how am I going to replace your sexual partner? What does that mean? And so, we had this long, they said, it's your study. You should have worried about this before the study. So that was an unusual recommendation. So on this, the 10th meeting, I went in the room, said, maybe you'll tell me something. We're very interested. It's very anxiety-provoking. It's 3 hours outside the room waiting for them. They're looking at all your data. And then we went in the room, and I sat down, and they said, don't sit down. And they said, I guess I'll go back. They said, don't sit down. And I said, why shouldn't I sit down? They said, we have a recommendation. So I said, what's the recommendation? They said, we can't tell you the recommendation. So I said, okay, when will I learn the recommendation? They said, the NIH will tell you the recommendation after they deliberate the recommendation. So then we left, and a woman who worked with me for 14 years on the study was just crying hysterically, saying, I wasted my youth on this study. She said, I'm a hag. I can't believe this has happened to me. This is unbelievable that my youth is gone and there's nothing to show for it. It was an unbelievable. She was supposed to drive me to the airport, and she only drove me as far as a metro stop. And and this is a true story. So as I was getting out of the car, the phone rang, and it was the head of the NIAID, and he said, "Can you come over to NIAID?" And I said, "Yeah, sure." And I got back in the car, and we raced over to the National Institute of Health, and I had to get through security and out of the campus. They said, look, we're going to tell you the recommendation. And the recommendation was that the Oversight Board recommends the results of the trial be made public. So we said, what does that mean? Now, in front of them was a stack of paper as big as Bill, as big as Bill Roper is tall, and he's a pretty tall guy. There was a huge stack of paper of everything that had happened for 10 years. So the question is, why did they want us to make the results public? So this is what they saw. They saw that there were 39 transmission events. So the index case transmitted to a partner on 39 occasions. Now, 11 of those times, no matter how much counseling we did, they were unlinked. That means the partners were unfaithful, and the virus that was acquired in those cases was acquired from somebody else. 28 of those transmissions were linked, and of those 28 linked transmissions, only one occurred in somebody receiving pills, and the other 28 received in people not receiving pills. This demonstrated 96.4% prevention of HIV transmission by taking these pills. So does everybody understand that? So we had essentially fulfilled our hypothesis. We had aborted HIV transmission by treating the patient. And the one case, Ron Swanstrom's group reported about 2 years ago that this particular person almost certainly came to the clinic, got their pills, and started having unprotected sex as soon as they took their pills, which wasn't the goal, right? You're supposed to take your pills for several weeks. So that it was probably 100% effective. Now, next year, the trial is still ongoing. The trial ends in May of 2015. We will have a subsequent report. This is about the effectiveness. Next, we'll report the durability over 5 years. But I can kind of hint to you, this will be a very favorable report. So we also looked at health, and we showed that we could stop tuberculosis half the time by treating people earlier. And this was published only 2 years ago. So we had improved health and stopped the transmission of HIV. And as was said, this became the breakthrough of the year in Science magazine. This is Bruce Alberts. Notice the most expensive and important slide of the whole talk. His mouth is about to move. Okay, so this is really important to this lecture. I'm going to go back. Look at how his mouth moves. That's never, I promise you that in the history of this lecture, no one ever made a mouth move. So this was the science breakthrough of the year, and Bruce Alberts indicated this was an unimaginable, quote, discovery. And then we learned subsequently that the runner-up was a mission of a spaceship from the Japanese to an asteroid called Itokawa, and it took $2.7 billion in 11 years, and this was the cover of Science, displaced. So you can, this was what should have appeared on the cover of Science. And so you can imagine in Tokyo they were really unhappy because they had generated this picture, and instead we have this picture. I feel bad about this, but it is what it is. So subsequently, this became a worldwide event. People, I think, hyperbolically said this would be the end of AIDS because we had discovered at least one strategy that would reduce transmission effectively. Hillary Clinton reported the AIDS-free generation, building on this, and then all policies all over the world changed. And the policies changed such that people would be treated earlier for their HIV infection. And the treatment as prevention movement became a movement of not just treating people for their own health, but treating them for the safety of the public, the health of the public, and for the sanctity of their sexual partner. And that was obviously encouraging. But there's a lot of work yet to do. So this is an idea, this is an aspiration. We demonstrated that under these circumstances, this can work. But people have to be tested, and once they're tested, they have to find their way to medical care. And when they find their way to medical care, there have to be pills available to take, the 1 pill a day, and then they have to agree to take the pill, and for right now, they have to take the pill for the rest of their life. So the challenge is not over. The challenge, you have a tool, but you can't really completely deploy the tool, although things are getting better. Look at this slide, which is the number of people being treated for HIV for all the benefits we've talked about from 2003 onward. And you see the trend is enormously positive, with I'd say about 10 million people being treated now, and probably 15 million people to be treated in the next 2 or 3 years. But we need 35 million people to be treated. We need everybody to be treated to maximize the benefit of this. Lots of mathematical modelers have worked on how this works out. What is the best benefit we can get out of this strategy? But the challenges exist. the HIV Prevention Trials Network moves on. And so now we're taking this discovery and deploying it. And the way it's being deployed is in another trial called PopART. And that's being done in South Africa and Zambia to test in 1.2 million people whether we can treat enough people to change the trajectory of the epidemic in the communities involved. This is a community randomized trial. The study's ongoing. It'll finish in 2 years. There are 4 parallel studies being done. They're very expensive trials, but it's kind of a marketing study to say, here's the tool, deploy the tool, and here's what might work out. So HIV research has not been static. In 1987, there was no antiviral therapy. As I said, the kind of courageous patients and their families and the physicians, many of whom continue to work here for all these years, and the nurses, who are the nurses that volunteered at a time of maximal fear. Remember, in 87, the fear you see today, Charlie Van Horst was talking to me about this today, the fear that we see with Ebola is the same fear that existed in 84 and 85 with HIV. So we see this over and over again in our species as new infections surface. It's not irrational. People have every reason to be afraid. But look at the change that's possible in modern public health and medicine. No ART, AZT alone, triple drug therapy, 1 pill a day, the 052 discovery, and now we have injectable agents that last for 2 to 3 months. So now we're exploring, Joe Yeargan, who I think is probably here, he's exploring the combination of shots that you take 1 shot every 3 months for your treatment. So we're trying to make this easier and easier and easier and better and better and better. So what about me? So this to me, always coming back to what's important, this to me was really a privilege to work here. It's great to have a chance to talk about this work. As I've said over and over, it was really like I got to be a leader over many, many years, and that was great, but it was about a lot of people working together. And for me, I got to take care of patients. I got to teach students from many different disciplines through different departments, and I got to do collaborative research with really smart people that were only limited not by the institution's boundaries, but by the imagination of the investigators. I want to give special thanks to Joe Pagano and Fred Sparling, who hired me essentially together. It was just, in the beginning, this is the whole infectious disease group, basically, with a couple of other people. So it's been a very long time we've been together. I want to thank both of them. Richard Root, my late mentor, who really was critical, very good friend of Fred's and mine, and who helped me throughout my career till his demise. So it's been a real privilege. Time goes on. This is my little daughter, Jessie, who's now an adult woman with all these children and another one born 4 days ago. So she's got fertility on her side, that's for sure. And so look at the little kid next to and I don't know what happened to the PLA soldier. I've looked for him for many years, the little soldier next to her. He's somewhere out there, and if I could identify where he is, that would be a really great ending. And let me indicate as I end this, very briefly, Bill, very short, right? This is timely, agreed, Bill? Not too long. So as I end this, let me say, it's not about, for us, and I'm sure it's true of all the people I work with, it's not about what was yesterday. It's about what we do next, okay? This is great. We got a chance to do all this, and I got a chance to have a whole career in one place that I've summarized in 27 minutes. But really, the faculty are continuing to work tirelessly on this and other infectious diseases, and Dave Margolis and Victor Garcia are leading a tremendous effort. They're probably the leaders in the world in looking to ways to cure HIV. And so we're not done because we've had some success. Joe Yeargan and his group have done tremendous work with treatment. I think we've made a contribution to prevention. Dave Margolis and his team and Victor Garcia are working on the cure for HIV, which is well-funded, tremendously exciting. So I want to thank you all for being here, and let's look to what happens next. Thank you.
I told you he was a force of nature. It's probably not in my interest to tell you this, especially those of you that are newly come to Chapel Hill. We welcome you again, but I was reflecting as Mike was talking across the more than 10 years now that I've been privileged to have this job and have been working with him. He's come to me many times with wild schemes, and I can't think of a single time I've said no. So that's what I mean. It's probably not in my interest to tell you that, but Mike has done an amazing job tonight of telling you the story of what makes this place special. We come together each year with the Berryhill Lecture to celebrate our history in the person of Norma Berryhill and Reese and the family and the past of this medical school, to celebrate the present, and Mike has told us the wonderful things that he and his team together have accomplished, and to celebrate our future. Again, we welcome those of you who are newly come. There is a prize that goes with the Berryhill lecture, and I'm going to give it to Mike in a minute. When we are dismissed, there's a reception in the back. Please stay and linger and enjoy each other's company. As well, we want to ask the previous Berryhill lecturers if you'd come up to the front, and we've got a photographer. We want to get your picture. Before I dismiss you, at the beginning I should have recognized Gail Henderson, who's the other half of this amazing couple. Gail, would you stand up so we can recognize you? So thank you, Mike. Thank you, everybody.